Mic testing. So yeah, so this is the session whereby we are talking about note taking of nuclear particles. This is unit 4. And the chapter is nuclear particles, nuclear and particles. So the first part you're going to look at is the scattering experiment, where alpha particles were directed to what we call a foil, gold lever. So what was observed that some of the particles were deflected. Some of particles were deflected at small angle. What does that mean? That means that much of the space occupied by an atom is empty. Yeah. So if very few were deflected and many passed through and deflected, but if very few were deflected, or with very small deflection, it means that most of the atom is empty. Then it was seen that only some alpha particles were deflected at an angle that is more than 90. So meaning they collided with the nucleus, so they could not be able to go beyond that. They could just deflected back. So which means that the central section of a nucleus of an atom, mass is concentrated at the center. So that's why if there is an alpha particle moving that direction, hit the nucleus, is going to bounce back because the center is very massive. So that's some of the conclusions that were able to be made in this particular scattering experiment. Also, it was observed that few particles deflected back, so which means that the center is very, very small. Then the next area that you need to understand, or you need to have a good understanding on, is the section of electron beams. So if streams of electron are directed to a crystal, they are going to cause what we call interference. You are going to see interference. Also, they are going to display what we call diffraction. So diffraction and interference are properties of waves. Only waves can interfere and can also diffract. Then for that reason, it was concluded that electrons can behave as waves, at the same time can behave as particles. So this is what we call the duality nature of electrons or light, because light can behave as waves, and at the same time it can behave as particles, which is observed in photoelectric effect. But as waves, we only focus on the behavior that is displayed when we are talking about interference and diffraction. There is the concept of thermionic emission. Remember, when we are talking about thermionic emission, is the release of electrons from the surface due to the heating process. If you heat this substance or you subject it to a hot heater, the electrons will start to vibrate, then they will be ejected from the surface, and that's what we call thermionic emission. But photoelectric effect is when an electromagnetic radiation is shown on the surface and then an electron is going to be ejected from that surface. That's what we call thermionic emission. due to the heat, but for photoelectric effect is due to the radiations that are coming from when radiations are subjected or are directed to a metal surface. They are going to give energy in terms of photons. That energy that is applied is going to make the electrons to be released from the surface. The energy of an electron can be given by the formula electron charge times the voltage, the PD, in which of the field in which it's moving. So kinetic energy is equals to the charge of an electron times the PD under which is being accelerated. So which means that if you are having energy, kinetic energy as a half mv squared, we can be able to comfortably say that this equation can be rearranged so that you can be able to make v, which is the velocity subject, which is going to be 2 times ev over the mass of that particular electron. Now, in terms of probing electrons, we have said that electrons can behave as electrons. Electrons can behave as waves, as also they can be able to behave as particles. Now, if they can behave as waves, then it means that they are going to have wavelength, because we learned from waves that the distance between a crest and a crest, that is going to give us what? The wavelength. But since we have said that particles, electrons, can behave as waves, then it means we can be able to find its wavelength. And de Broglie came up with a proposal that wavelength of electron, that is and moving, they're going to have this particular wavelength whereby it's Planck's constant divided by the momentum. The particle's wavelength is going to be equals to Planck's constant divided by the momentum. The diffraction can only be obtained if the electron beam had the wavelength that was de Broglie's wavelength. Yeah, so the diffraction that we are talking about, that can be able to be experienced by these electrons, can only occur, can only happen in the event the electrons are having the Broglie wavelength, and the Broglie wavelength is calculated by this formula, Planck's constant of the momentum. Now, the next part that we are going to look at is what we call particle accelerators and detectors. And something that you need to appreciate in this section is that these particle accelerators, they make use of electric fields and also magnetic field. Electric fields to accelerate the particles, because already we have mentioned that particles will experience a force whenever they are moving in an electric field. And if they experience a force while they are moving in an electric field, it will mean they are going to have what we call high speed. They are going to have high speed. They are going to experience the force, so they are going to be accelerated. They will be able to move. So particles are collided at high speed in collision as energy. Remember, particle accelerators, these are machines that enables particles to be collided at high velocity. So at high velocity, when they collide, they can be able to disintegrate and break, so that now the scientists can be able to study the internal structures of those particles. So something that you need to put into consideration and perspective is the fact that these particle accelerators, the main purpose of it is to accelerate particles so that the particles collide, and in the process of colliding at high energy they are going to disintegrate, break, so that now they can be able to study the internal structures of those particles. Basically that's the purpose of that. So the acceleration is done to be at high, very high speed, so that the particles will have enough energy in the event there is any repulsive forces, that repulsive forces can be able to be overcome. So this is achieved, this accelerating particles is achieved by the fact that there are electric fields which accelerate them. Also we have magnetic field, and the magnetic fields are going to bend those particular particles in the process so that they can be able to take the path that is required. We have types of accelerators. We have one which we call linear accelerators, and these are famously known as LINAC accelerators. You are going to learn about LINAC, and I believe maybe you've learned about them. This is what we call what? LINAC, linear accelerators. So these linear accelerators are just machines which accelerate particles like electrons at a very high speed. And this is achieved because if the particles are made to be accelerated and different voltages are connected to the plates, then this high speed is going to be achieved. So we need to identify a few sections. Yeah, the key advantage is that the key advantage for that, let's try to write a little bit more on that. Yeah, so let me just focus here. So we are going to say its key advantage, the key advantage of a LINAC. The key advantage of a LINAC is that very high energies is that its key advantage is achieving, let me say, achieving so which means that if potential difference is applied at multiple stages, it means very high speed can be achieved through this LINAC. How does it work? How does a LINAC work? So we are going to highlight now how it works. How a LINAC works. That's now the area that we are going to focus on, so that you understand how this linear accelerator work. We have different stages. So we have staged acceleration, number one. We're going to talk about staged acceleration. whereby we can say particles Then we have the next section, alternating voltage.